Welcome to Module 3, Lesson 3, Subtracting Rational Numbers. Today we're going to talk about understanding the subtraction of rational numbers as adding the additive inverse. And then we're also going to talk about the distance principle using rational numbers. Alright, so first we have to remember is that when we're subtracting with integers, we're actually changing that to adding the opposite. Right, so instead of doing 5.5, so in this case, we're starting with 5.5 degrees, and then on Thursday, it was 7 25/100 degrees less than the temperature on Monday. So what that tells me is I'm doing 5.5 minus 7 25/100. Right, well in this case, if I'm on a number line, I can start at 5.5, and I can drop back 7 25/100. However, we're not always going to have a number line around us, so what we're looking at here is how we are going to do this mathematically, all right? But regardless, you're going to move 7 25/100, and because it's subtraction, we're moving to the left. So subtraction always tells us to move to the left. We also have to think though. So subtraction says move to the left. But then we also know from the previous lesson that adding a negative also tells us to move to the left. So these two things are actually telling us to do the same thing. So minus 7 25/100 is actually telling me to move left on a number line. Well, since I'm not using a number line and I know rules of addition, if I change this to the same thing, so plus negative 7 25/100, okay, so plus a negative tells me to do that same thing. So as long as this part, so as long as what I was being told to do up here matches what I'm told to do down here, I can change it around. Okay, so this one said move left. Together, these two tell me to move left. So they mean the same thing. When I'm adding with opposite signs, I know that I find the larger absolute value, which in this case is negative 7 25/100, and I subtract those absolute values. 5 minus 0 is 5. 12 minus 5 is 7. Okay, and then 6 minus 5 is 1. So in this case, my answer is that the temperature on Thursday was negative 1 75/100 degrees Celsius. Right, so like I said, as long as what you're telling me to do mathematically is the same as what the original problem tells you to do, it's okay to change subtraction to addition because it's the same concept. So in this case, if I look at this subtraction problem tells me to move left, okay, because it's minus a positive. Well, I also know that plus a negative tells me to move left. So I can change this to negative 6.5 plus negative 2. And I know that since it's a negative plus a negative, I can just add them and keep the sign. So my answer in this case would be a negative 8.5. And if I check that, so negative 6.5, and if I move to the left 2, so 1, 2, I know I get the same answer. Okay, and again, 1.5, so 1.5 minus 2, so 1, 2, I should get negative 1/2. Well, again, 1 and 1/2 plus a negative 2 tells me to do the same thing. It tells me to go to the left. So I can change it to plus a negative because plus a negative also tells me to move left. So I can use my addition rule. So 1.5 and 2 are going to be subtracted. I know that 2 has the greater absolute value, so I know my answer has to be negative. I know that I have to borrow from the 2, so I'm left with 1 whole. That other 1 whole turns into 2 halves. 2 minus 1 is 1 over 2. 1 minus 1 is 0. So my answer is negative 1/2. I got the same thing. So again, here we're just focusing on subtracting a positive, and I know subtracting a positive, so minus, and I'll even put a P for positive, tells me to move left. Since it tells me to move left, I can change it to adding a negative because that also tells me to move left. All right, so here I have negative 2 and 25/100ths, and I can change minus that positive to plus a negative. Now I have a negative plus a negative, which tells me I can just add and keep the sign. So I should get negative 7 and 75/100ths. Okay. So let's check this out again. So subtracting negative rational numbers. So now I have a negative minus a negative. Well, during the hottest week of the summer, the water level of the Muskrat River was 5/6 of a foot below normal. The following week, it was 1/3 foot below normal. What was the overall change? Okay, so in this case, I know that it was negative 5/6 foot below level, and then it was only 1/3 of a foot below level. So I want to find the difference between those two, so I know that I have to subtract. And I'm subtracting my starting value minus my ending value. Now, I know that subtraction tells me to go left, but then this negative undoes that and says to go right. So minus a negative tells me to move right on my number line. Well, the other thing that tells me to move right on my number line is plus a positive. So since plus a positive tells me to move right, that's doing the addition of the opposite. So negative 5/6 plus the opposite of 1/3, negative, which is positive 1/3. Okay, so that minus a negative turns into plus a positive because both of them tell us to do this, to move right. Now I know that because my signs are different, I'm actually going to subtract and then use the absolute value to determine my sign. But because it's 1/3, I have to change my 3 to be a 6, so that way I can actually subtract because I need to have common denominators. So 3 times 2 gives me 6, so I have to multiply the top by 2. Because if I chop each of these 3 pieces into 2 pieces each, I also have to do that to my numerator. So in this case, I get negative 5/6 plus 2/6. I know that negative 5/6 has the higher absolute value. I'm going to subtract 5/6 minus 2/6, and I get 3/6. And I know my answer has to be negative because negative 5/6 had the higher absolute value. Okay, and I also know that this can reduce down to negative 1/2. So the difference in water levels was a drop, or was 1/2 of a foot. Okay, and then again, because we're just talking about the distance of the two, this is going to be that absolute value problem. So we don't care if it went up or down, we just want to know the change in the value. So since we just want the change, all we want to know is that the change was 1/2 a foot. Okay, so work with other students to compare addition of negative numbers on a number line to subtractions of a negative number on a number line. We'll talk about that a little bit more in class and just the commonalities and differences that you found. And then actually with number 5, we don't need to do that. We're just going to, I want you to answer this one and we're going to have a discussion about that in class. So that should be a little star there telling you to do it. All right, so now we're gonna, instead of using a number line, we're gonna do the math. So again, we're going to add the opposite. So subtraction tells us we can actually add the opposite. So instead of doing 0 and 25 hundredths minus a negative 1 and 50 hundredths, we're gonna do 0 and 25 hundredths plus a positive 1 and 50 hundredths. Now I can just add these the way that they are because they have the same sign, so I add and keep the sign. In this case, I have negative 1/2, and it's minus a negative 3/4, so we're going to add a positive 3/4. To do that, I have to change my denominators, so I know 1/2 has to change to something over 4. I multiply by 2, and I multiply by 2, and I get 2/4. So in this case, it turns into negative 2/4 plus 3/4. Okay, they're different signs. 3/4 has the greater absolute value. All I actually do is 3/4 minus 2/4, and I get 1/4. So my answer in this case is a positive 1/4. All right, so again, focusing on adding the opposite. So in this case, subtraction of 7.5 tells us to move left. Okay, but I don't have rules for subtraction. So even though I'm using subtraction, in order to do the math, I'm going to change it to addition. Because if you look at the number line, so I start at negative 2 and 1/2, and it tells me to move to the left 7.5. So 1, 2, 3, 4, 5, 6, 7. Okay, and then 1/2, so I would end up at negative 10. Okay, so it's telling me to move to the left. Okay, and it's because you're subtracting a positive number. All right, so Joe is 10 feet below Again, remember that as long as what the problem is telling you to do is mirroring what the original says, you're fine. So this one, so negative 2 and 1/2 minus 7.5, this tells you to move left. So I know that I can keep negative 2.5 because I have to keep my starting point, and I know that adding a negative is the same thing as subtracting a positive because these two things here still tell me to move left. Right, so here I have negative 3 minus 3. Instead of using the line, we're going to change it. So negative 3 minus 3 tells me to do negative 3 plus a negative 3. Negative and negative, I add and keep the sign. Okay, and then here, negative 3 plus a negative 3. Well, negative 3 plus a negative 3, I'm still going to the left. And I'm getting that negative 6 again. Okay? Right, and don't worry about this conjecture. We're just going to keep going with our practice here. All right, so now we're talking about the distance principle. Okay, so a cave explorer climbed from an elevation of negative 11 meters to an elevation of negative 5 meters. So we want to know what vertical distance did that person climb. So the start was at negative 11, and then if we start at negative 11 and go up to negative 5, I know that this is 6 units, or 6 meters. Okay, so the explorer climbed 6 meters. This means the vertical distance between the negative 11 and negative 5 is 6 meters. But now, if I actually do the math, so if I want to actually find the difference, I would do negative 11 minus a negative 5. Now, if I actually do that, I end up getting a negative 6 as an answer. But again, the person climbed up. And we're just looking for the change. So we're just looking for the change in elevation. And right now, we don't care if it was up or down. So that's why we use the absolute value. Okay, because we know that he actually went up, but in this case, because we're using subtraction to find the difference, we're getting a negative number. So we use that absolute value to keep us from getting the negative and just get an answer of how far. All right, so if I use the absolute value, I get the same thing as I got on the number line of just going up those 6 meters. So again, when I just want to know the difference, when I don't care about up or down, I use that absolute value. Okay, so does it matter which way you subtract the values when finding distance? So does it matter which way you subtract the values? And would the same methods work if both the numbers were positive? What if one of the numbers were negative? I want you to answer these on your own, and they're also going to be part of our discussion on the next class. Okay, and then you also have your guided practice problems here. I know that this is a little difficult, so slow down, show your work. Don't worry about using the number line. So I see that it tells you to use the number line here. I'm not worried about this. I want you to practice your addition and subtraction with fractions and decimals, all right? And then I also want you to practice using that distance principle when we're just looking for how far. We don't care which direction, just how far. As always, if you have any questions, please be sure to email me or write them down so we can go over them in class.